Hello, I'm Elena Yatzek, and I am here to present about dimensions that contribute to winning at Eurovision, which is an annual song contest in Europe, if you are not familiar with it. So here's my presentation. All right, so Eurovision is a song contest. Let me start with an introduction. Uh, um, I am, as I said, Elena Yatzek. I'm a senior product management leader. I am currently working to beef up my data engineering and business intelligence skills, for which purpose I enrolled in the Savvy Coder Bootcamp for data analysis. During the time, the main focuses I had was at learning more about web scraping, data cleaning, Python, Bash, GitHub. I had experience already in SQL, Tableau, and Excel, but I've also been trying to get myself into more of a business intelligence mindset as opposed to getting a new piece of software out the door mindset, because I think both are very important. In terms of the project, I picked Eurovision because it is fun, first and foremost, and it offers some interesting data scraping challenges. But if you are not familiar, it is a song contest that dates to 1957. And I explain a little bit more, but there are a lot of interesting dimensions in Eurovision in and of itself without even looking at what allows you to win. So, relevant ground rules. It is held in May. If you are watching the headlines for Eurovision content, which I am, you'll see that they just announced the UK entrant for this year. So the process for Eurovision right now is that the individual countries are picking who they will be sending in May to the finals, the semifinals and the finals. The winners are determined by country-based public voting, and all the contestants are arranged into two semifinals. And in the semifinals, there's a completely 100% public vote in which nobody is allowed to vote for someone from their own country. So you can choose anyone you want, but it can't be your team, which is backwards for most of us Americans. After the semifinals, the top 10 from each semifinal, plus the 5 sponsoring countries, known as the Big Five, and these are the ones that provide the most financial backing for the Eurovision contest, have a sort of final round. And in the final round, the voting is actually a combination of the same kind of public voting, but to avoid people being, unfair in any way, every country has a public vote plus a vote that is made by jurors who have some kind of credentials for voting on whether a song is good or not. And that seems to have stabilized the results. That is an assertion I haven't actually tested with the data, so I'm just repeating what I have read. So the data problems that I'm considering, I mean, the title of my presentation about how to win is a bit of an overstatement. I'm looking at two specific dimensions. One is it true that people win because they vote in blocks? So all of Scandinavia votes for whoever the Scandinavian countries are that are in the finals. All of the Baltic states vote for Baltic states and so on. And then there have also been allegations that who wins is determined by order of performance, like people who perform last always win. So those were the two things I wanted to actually look at data to consider. All right. The process that I followed is the process that we really had drummed into us during the Savvy Bootcamp, which is there is an actual sort of life cycle for data science in which you find out, you understand what your business problem is, you get the data to support your analysis, you do what you need to do to put the data into a format that you can actually explore with tools. Then you do the exploration. There may be some additional calculations you need to do in terms of creating aggregations or something else that modifies the data, not to change its meaning, but to gather it in a different way to make it a little bit more friendly for visualization. If you were doing actual data science, there'd be some modeling to look at the predictive value of your data. That was not part of the boot camp, so I didn't do that here, but it's very cool, and I would love to try that someday. And then you finally take what you have and present it in a visualization tool. The two main ones out in the market are Tableau and Microsoft Power BI. The tool we use at Savvy is called Tableau, which we're in. So the main data challenge that I faced in terms of getting the data in order to make the presentation was that in order to find out, for example, what the order was that people performed in for every one of the Eurovision contests since 1957, comes off of a page that looks like this, where there's a big menu of here's some different views we'll give you of Eurovision data. And then you press a button on that screen, and then it brings up a response page that has all the data on it. So your first impulse, or at least if you're me, your first impulse might be, I'm not going to bother with tools. I will just go ahead and press the button for all the times that it takes and then do a cut and paste of this data into Excel. But I tried that once or twice and it wasn't actually very good. Plus, it didn't really exercise the tools that we were trying to learn in Savvy. So I quickly realized that what I needed to do was some kind of actual automated data scraping. The second problem, so you can see how just bringing up this page that shows, just bring up a page that shows for this year, here's what the place was for each company and here's what order they performed. That would be a little bit onerous. But if you wanted to know who all the voters from each country voted for every one of the years since 1957, that turns out to be 2,652 different times that you'd be pressing a button. So for example, this page shows just Belgium votes for Andorra over those last few years. And picture doing that 2,600 times. So that was something I definitely did not want to do. And it was a very fun challenge to be able to do it automatically. So how did that work? There's a tool called Inspect that belongs to Google Chrome. And one of the things we learned in the program was playing around with Inspect to find out what to do. So you could actually automate the process of bringing up a page and scraping the data off of it. So I used Google Chrome Inspect to find out exactly what what post call was made in order to bring up that second result page. And then once the page came up, I could use standard HTML data scraping tools. There were other more fancy things that you can do involving getting data from APIs. That wasn't necessary here. All I needed to do was render the page and pull data off of the page using a standard tool that's built into Python pandas called Get HTML, which I have to say is just incredibly cool. So you have a table here, and once you know what the page is, all you do is tell the get HTML you just have one line of code that says get HTML, go get me the second table on the page, which is what that one happens to be, and put it into a pandas data frame. And now I'm going to do some data manipulation on it. So essentially the most complicated thing I did probably for the whole presentation was setting up a loop within a loop in which I called the page that showed the voting results for each country against each other country, all the possible times. And within each loop, I had to create a call from I would bring up the year, and then within the year, I would bring up which countries voted for which country, which way. So there was an embedded loop. Within the loop, there was just one line, get HTML, and then there was sort of a sorted data cleaning that went on after that. Let's see. Okay, so that said, two data questions. The first one is recency effect. So does today's Eurovision finalist have an advantage if they perform in the second half of the final, which was something that was actually alleged by this guy Han in 2005 in a study. So he found that consistently, or at least there was a pattern, that if contestants performed later in the sequence, they received higher scores. It didn't matter as much in 2005 because those positions of performance were assigned randomly. But as of 2009, the producers stopped assigning them randomly and started assigning them in a way that they thought would lead to a better show for the millions of viewers across Europe that were watching it every year. And so people had to ask, well, could this have introduced bias? Are these producers somehow colluding to put their favorite people last? So the questions that I wanted to ask was, first, is there actually a recency effect? Another effect that has been proposed is a thing called primacy effect, which is a combination of either you remember them because they were the first ones, or you remember them because they were recent, but you probably don't remember them in the middle. So the question is, does order matter? And if so, is there some reason to think that there could be bias? So this is the first sort of Tableau dashboard that I built in order to do the inquiry. So this starts, this is a filter that you can apply. So this shows you actually from 1956 to 2023, who won at each position in the lineup. So what it's telling us here is the person who went 17th won 7 times overall since 1956. And then positions 14, 9, and 8 were winners 5 times. Then we went down to 4 and so on. However, so you might think, oh, okay, well, so it's pretty clear that what you want to do is make sure your contestant goes at the 17th place. But it's not quite that simple. For one thing, the number of contestants changed over the years. So in the first year, there were 14 contestants, and then it went down to 10. And then it went back up a little bit. It's been pretty consistently hovering at around 25 or 26 for the last few years since about 2000. So if you adjust uh, the positions to the overall number of people competing in the year, you get something that's a little bit more predictive and creates an apples to apples comparison from one year to the other, which is called quartiles. So, given a certain number of performers, did your country perform in the first 25%, the second, the third, or the last? And if you look at that, you see, interestingly, that neither the first nor the last seems to have done the best. In fact, the winning position seemed to be in the second position, just before intermission, the second quartile. This changes, however, depending on which years you choose. So if you start with the Han proposal, which is that it was really best to go last. So I'm switching this to be 56 to 2005. What's interesting to me here is that this shows first position was winning in those years the most, and second was at the 25th percentile, was the second most popular. And in fact, going last was the least likely to make you a winner. So I think that a person with a little bit more time and more statistical background would be able to talk about how Han came to his conclusion. One of the more obvious ideas is that he's looking at the total number of points and not necessarily whether or not the country placed first. But in any event, in that time period, it seems pretty clear that going first was better than going last. Yeah, the second question I had was, okay, well, if you look at what happens between, say, 2009, when they changed whether it would happen in order, and 2023, which was the last Eurovision, then what happened? Here, nobody who went in the first quartile took the first place position. And again, just as we saw for the whole population, just before intermission was the winningest place to be. Although being in the second half, if you add those two together, it was probably better overall to be in the second half, but definitely you wouldn't want to go first. So the data doesn't totally support either the concept of a recency effect or even the concept of a primacy effect. It seems overall like it's also a pretty small sample size. The whole population is so small that predictive value seems a little bit questionable. So I don't think we can actually conclude that being in a specific place in the lineup makes a lot of difference, except possibly being in the second half would be better than being in the first. All right. Second data question, and this is the diagram that really inspired me to do this presentation, is what about the block voting? And I'm sure it's not that legible to you, but this is sort of like, this is the Soviet block, and this is called the Nordic clique. And over here, we've got the German mini block and so on. So they've got caricatures suggesting that the voting in blocks might be the winning strategy. So it's fun to talk about. It's fun to sort of speculate if you're in a pub in, Berlin complaining about what's going on at the Eurovision. So this next section is for all of you who might be doing that so that you could have data at your fingertips to talk about that. So first of all, in order to turn this into something a little bit more rigorous, I had to define some blocks. So I actually defined a bunch of blocks, but it turned out to be a little bit unwieldy to present all of them. So for the purposes of the presentation, I created one block that was just the big five. These are the major sponsors of Eurovision. And just so you know, this is like the number of years each of these countries performed and the number of times that they won within those years. The other blocks that I looked at, one was Scandinavia, because I think everybody who knows anything at all about Eurovision knows that ABBA won with Waterloo back in the day. So we all kind of think perhaps that the Nordic vote is always going to a Nordic recipient. And when you look at it, you see that Sweden has performed quite a lot of years. Sweden has won a whole bunch. Did they win mainly because of other Nordic countries voting for them? That's something we need to find out. And then I think the final block that I put together for purposes of the presentation was the Baltic block. And this is sort of down around the Mediterranean, Greece, Turkey, Croatia, and so on. So when you look over the years, the question would be, is there block voting? And it's a little bit difficult, again, because the number of contestants in every year changes. And also the distribution of the overall votes changes. So UK getting first in a specific year means that they got some total number of votes and that all the other votes were distributed in a way so that everybody else, everybody else's total number of points was less than theirs. But the distribution of points across all 60 contestants, or for the final all 25 contestants, is something that is not easy to sort of capture. So what I did for the purposes of the investigation was say, let's look at the proportion of votes each country got in each year. So we can say, would block voting have made a difference overall in that total number of votes? So if we look at, for example, this is the total winning proportional votes. So UK didn't, as we know, win all those years. But if you put together all the votes that they got in all the finals, they got the most. And then France got the second most, Sweden got the third most. This is in terms of proportions per year. Right now we're seeing before and after being equal. But if we filter to say, let's just look, if we only consider how the Nordic countries voted, would it change? And the answer is yes. Sweden now surges ahead. United Kingdom is in second. And then I think, yeah, Denmark definitely moves way up. Norway is way up compared to where it was, and so on. So you can definitely see that if you look at a specific voting block, in this case, the Scandinavian block, it would have made a difference, but it wouldn't have made a complete difference. It wasn't like we suddenly just saw the Scandinavian block at the top of the list. We can also check the Balkan choice to see what difference it would make. And we see the same basic thing. Instead of the United Kingdom, suddenly Spain is at the top, then Italy, UK falls down to third, then Ireland, then Sweden, and so on. So it is definitely the case in a very observable way that if you choose one specific voting block, as defined by such a noted resource as Wikipedia, and you say, if they ruled the world and they were the only ones who get to vote, would it have changed the outcome? And the answer is pretty clearly yes. So this is a bit, though, sort of like, okay, proportional votes, what does that really mean? So for purposes of people who are actually curious about this, you can see exactly how it would have changed the outcome for any given year. So if we look at 2023, Sweden won by a mile, followed by Finland. And if we look at the Balkan choice, would that still have happened? Well, yes, Sweden still would have won, but Israel would have come in second, which is kind of interesting. And then Finland, and then Slovenia. So there's an impact, but it is not sort of a decisive impact. It appears that perhaps the song itself has an impact on what the actual result is. So my conclusion is, does the recency effect hold true after 2025? What we found was recency effect didn't even seem to be true up to 2025. And it also didn't particularly seem to be true in the years between 2009 and 2023, although you could argue being in the second half, broadly speaking, was a better option than being in the first half. Although the most absolute number of winners happened in the first group before the intermission. In terms of voting blocks, do they vote in blocks and does it impact the outcome? Answer, yes, but not to the point that it actually changes the outcome altogether in terms of total number of votes. It could push your country to a winning position that it wouldn't have had before, but a lot of other things need to go right, including the rest of the world voting in a way that supports your conclusion. So that's pretty much it. I need to thank Savvy Coders for making this whole thing possible. Ann Simmons, a friend of mine, gave me the infographic about block voting that inspired the entire talk. And Greg Sandell, a friend of mine, really helped me a lot with the Google Chrome inspect calculations to determine how to do that web scraping, which is a thing that you need to do a couple of times before you really master it. So thank you again so much. It's been great.